Assalamualaikum and good greetings. This will be a simulation for final exam question, meaning answering final exam question. This final exam question is from semester 1, 2021-2022. Right, so given that this is a simulation, so the focus is answering the question using strategies that will help within the allocated time. So the focus is that if you have done these particular questions and you just want to check for the answer, you can straightway skip to where we have found the answer. But if you are trying, to attempt this particular question and see if you can answer it with the allocated time, feel free to go along and write and answer on your own, but while we are doing it together, right? Do not follow what I write or how I calculate, but do parallel in the same time and see whether we get the same answer, etc. Now, given that this is a simulation, I will be attempting to answer this question in real time so that you can see in terms of the time usage and whether we have sufficient time for each questions given. And given that it is me answering in real time, I may actually make some mistake just like in the midterm. Hence, that is where in the simulation I will actually apply checking rechecking approach, so that just like in the midterm question simulation, I did make actually some mistake, and then when I realize it, I have to recalculate, and actually we can still manage to calculate everything within the given time. So the time allocation is sufficient, even if you have to recalculate if you notice if you have done any mistake, right? So that's the nature of final exam, right? So without further ado, let's go through this question and see what we can do. Alright, so this is the exam question. So semester 1, 2021-2022, 3 hours is given, and then here, of course, at the beginning, okay, let's take a note of the time here. This is 3:35, so 3 hours, so we have from 3:35 to 6:35. That's the full time, and let's consider that time is already started and we are reading this using the time. So we have 4 questions given, so make sure you check all the information. So we have 7 pages and 4 questions. So we have 4 questions. Now, normally many students like to ask how many questions that will be there in the final exam. This is one of the questions that I do not really like to answer, because the answer can mislead you, because we will see, even though it is 4 questions, but under each question actually there can be multiple questions, right? So question 1A, 1B is actually 2 different questions. So in actual it's not 4, it's maybe 8, maybe 6, something like that. We will see, right? So anyway, and then here it says answer all questions and so on. Right, so we have question 1, for example here, 25 marks. Okay, by the way, in terms of time allocation, right? So here we have 25 marks, 25 marks, 25 marks, and 25 marks. Let me make it closer. So meaning that the 4 questions is evenly distributed in terms of marks. Hence, as a hint, that is meaning in terms of your time, dividing your time, you should finish each question within 1/4 of the time given. So 3 hours, 1 hour and a half, and meaning 45 minutes. For each question you should be able to solve in 45 minutes. So the first question we should be able to solve from 3:35 to 4:20. That's 45 minutes, and so on. Alright, so the time I've already started at the bottom right. Here you can see this already 3 minutes in, because we started at 3:35 just now, right? So that's just meaning that it's not a problem to have like 2 to 3 or 4 minutes to plan and make sure you have your strategy ready. Alright, so as you can see here, for question 1 there's A and B, which is totally different question. So within this first 45 minutes, which is already like 5 minutes is already almost up. So we have 40 minutes left. We should be able to solve for question 1A and 1B. Alright, so without further ado, let's address this question. Now, question 1A. Figure 1A, which is this one, show strat BC. Show BC strat. So this is BC here, right? Having a uniform self-weight of 0.8 kilonewton per meter. Okay, sorry. So we will use this one just to sketch some information. Let me use what is this one? Okay, so meaning that what is this? Okay, so this information means that this will be having a weight, right? Because it says it have self weight, meaning this beam having weight, and this is the density basically, right? 0.8 kilonewton per meter. So we have how many meter, and then we can calculate what is the kilonewton. Supported by a pin C, so there's a pin here, and a non-stretchable steel guy wire AB. So this is wire AB, non-stretchable, so we have a tension here. Find the strut support reaction. So what is the question 1, right? So that is the important thing. The question 1, support reaction. So meaning what is here, meaning you have CX CY here, and basically what is the tension here, right? So that's basically the question. First answering, knowing the question, and then addressing it. Alright, so so question 1A. Question 1. Alright. Okay, so it is good practice to actually write down what the question want to begin with, right? So at the end of the day, we have to find what was that? Support reaction at C, meaning that we have CX, CY. So that's the two component at pin C, and then we have to find what is FBA, right? Meaning that the force in the cable, the tension there, right? So first step, free body diagram. So we have free body diagram of BC or CB here, right? Okay, so we have this distributed loading. So let's deal with that distributed loading first. Let's go here. So when we have distributed loading like that, and at the end here is 4.2 kilonewton per meter. Okay, so it's like that. So we'll just, I think we do not need to do that. The equivalent should be somewhere here, where we have this 1/3 and 2/3 ratio, right? By now you should know this. And because this is 3 meters, so this should be 1 meter and 2 meter, right? 1/3 and 2/3 of the length, and the value here is just the area under the graph. So we have half times 4.2 if you write the unit kilonewton per meter, and then we have this 3 meter, right? So this is equivalent to 1 divided by 2 times 4.2 times 3. So you get 6.3 kilonewton, right? When you multiply the units. So verifying 1 divided by 2 times 4.2 times 3, 6.3. Alright, so 6.3 kilonewton there for that distributed loading. And for the weight, so let's go for weight. So we have 0.8 kilonewton per meter, and then we have the total length of 3 meter. So we'll have 0.8 times 3, you have 2.4 kilonewton. So those are the two forces that we need, right? So when you draw a free body diagram of this thing, right, so we have the weight at the middle. That should be the weight, and then we have basically this distributed loading, which is 1/3 of the distance, so it should be somewhere here. And then we have Cx and Cy, and as well as tension here. So we have this FAB or TBA, whatever label you want to call it. So I'll label it FBA here. So in terms of the support action over here, let's consider that. And normally, what is the logical? Let's just assume. Of course, this is assumption direction, right? So Cx, Cy. Okay, so this is 6.3 kilonewton, and this is 2.4. Oops. 2.4 kilonewton. And to complete it, the distance is a requirement. So this is 1 meter. This is 1.5 meter, right? Half of it. And the remaining is another 1.5 meter. So the total is 3 meter, right? So all the information, the important information is already here, so we can just continue the calculation, right? Alright, so the easiest one normally will start here, right? A moment about point, this is point C, right? So summation of moment about point C equal to 0. Let's take counterclockwise as positive. So from there we can have, okay, what's the angle? So the angle is missing when, okay, that's another thing. When you want to calculate, if some information is not there, for example, when I want to calculate moment, I need this angle, but this angle is not in my free body diagram, means your free body diagram is not yet complete, because all the information that you need in your equation of equilibrium have to be from the free body diagram, right? So okay, so what is the angle? So we have this triangle where this is 50 degrees, meaning this one, this one will be 40 degrees, right? Because the internal angle of triangle is 180. So this is 90 here. So 90, the remaining 90 minus 50 becomes 40 over here. Alright, so that's the free body diagram, the complete one. So we take the vertical FBA. So FBA sine 40 degrees, that's the vertical one, time the distance of 3, right? So time the distance of 3, that's counterclockwise. And then this 2.4 is clockwise, so minus 2.4 times the distance of 1.5, and then minus, because this 6.3 is also clockwise, so 6.3 times the distance of 1 equal to 0. So calculating, so minus 2.4 times 1.5 minus 6.3 times 1, you get 9.9, minus 9.9. So basically FBA cos 40 degrees times 3 equal to 9.9. So 9.9 divide by 3 and then divide by cos 40 becomes, so FBA equal to 4.308. This is in kilonewton, right? Ish, my paper is flying all over. Alright. Is that correct? So is there any mistake? Again, 2.4 2.4 times 1.5 plus 6.3, so 9.9. Divide by 3, divide by why is this suddenly cost? Okay, that's where I make a mistake, right? So that's where you should always check. How come this become cost? Where's the delete button? Astaghfirullah. Okay, so this would be sine. Oh, where's my this should be sine. How come from sine suddenly become cos? That's bizarre. Alright, so okay, this is a mistake. Fortunately, I do check. Okay, again, so 9.9 divide by 3 and then divide by sine 40 degrees. 5.13. Oops, where's this? 5.1339 E88, right? 5.1339. Basically, if you write in full, right? Of course, as a final answer, because now for calculation we do need this to have a lot of significant number, right? Because we will continue to calculate, we want to reduce the error. But as the final answer, because that is one of the answer that you need to give, so final answer is 5.1 oops sorry 13, right? Kilonewton as a 3 significant figure, right? But we will use the more accurate number for calculation, right? Okay, so that's number one. So going here, so we can use summation of fx. So summation of fx equal to 0 if we take count positive to the right. So basically what do we have? We have cx to the right, so cx, and then we have FBA to the left, FBA cos 40. So FBA we know already, which is this one, so minus 5.1339 cos 40 degrees equal to 0. So from here calculation we can straightway calculate. So 5.1339 times cos 40 3.9328 kilonewton, right? Or as a final answer, Cx equal to 3.93 kilonewton. Next we can have the summation of Fy, right? So summation of Fy equal to 0, positive upwards. So we have Cy upwards, so Cy, and then we have the two force downwards, right? So 6.3 and 2.4, so minus 6.3 and minus 2.4. So double check 6.3 and 2.4. Alright, and then FBA sine 40 upwards, so plus plus FBA is 5.1339 5.1339, then cos, no, it's not cos, it's sine, right? The y component, sine 40. 9 sine 40 degrees equal to 0. So calculating these numbers, minus 6.3 minus 2.4 plus 5.1339 times sine 40 degrees. So you get Cy, you get 5.39. Okay, so it's basically because 99999, so it's become 5.40, right? Right, because if you round out it becomes 5.40000 basically. Alright, so that's the answer for part A. question 1A, we have to find this three, right? CX, CY, and FBA. So there you go, FBA, CX, and CY. So we move on to question 1B. Okay, moving on, question 1B, right here, right? So just looking at the time, where's my note of the time here? We should answer this before 4:20 for the 45 minutes, right? So we have around 23 minutes. Okay, part B. Determine the resultant internal loadings in the beam shown in figure 1B, this one down here, at cross section through point D and E. Alright, so where is it? So the question actually wants us to find what is the internal loading here and here, right? D and E. Point E is just to the right of the 10 kilonewton load. Okay, so this is important, right? Oops. Because meaning that point E here, because if you look here, point E is at the bottom of this. But when you want to draw the free body diagram after you cut off that section, this force have to belong to the right or to the left, one of it. It cannot be both. So it's just said here, it's just to the right of 10 kilonewton, meaning that if you draw on the right part, you have this 10 kilonewton. If you draw on the left part, no, because it's to the right. Ignore the beam's own weight, so this doesn't have any weight. Alright, so to solve this kind of question, how to, okay, to solve this kind of question, whichever way, because you have some option, right? Because we have to cut something like this, right? For this, because there's two split question basically, right? If you cut here, you have to draw either this side or this side, right? And if you have to draw this side, you have to know this support action first. And if you want to draw on the right side, you have to know this support action first, right? Similarly, it goes with if you cut here, right? Then if you want to draw to the right, you have to know the support action, and to the left you have to know the support action, right? So any which way, you have to find support action first for this question. Alright, so let's go. So I hope you can still see this one. Alright, so let's take the key point first from question 1B. Where's my pen? So question 1B. So the question actually asks for the internal loadings, internal loadings. So at D and also at E. And internal loading means what? We have normal, we have shear, and we have a moment, right? Of course, this depends on which side. Meaning the direction depend on which side you draw, right? So this is an example, right? But you have these three values. So meaning for point D, you have to find N, V, and M, and point E, N, V, and M. All right. So first, finding support reaction. So we have to draw the full free body diagram first. Alright, basically you have two parts of this free body diagram. One is the left beam here from A to B, and then on the right B to C. Of course it depends on which side you want to use, but we will try to find, if we want to find everything, is there sufficient time. So let's see. So if you draw on the left side, it will be something like this. And then you have this distributed loading, right? So because it's even like that, so it should be at the middle, and the value will be 20 kilonewton per meter times the distance of 6. So 6 meter, right? If you want to use the units, so become 120 kilonewton, right? And then you have normal reaction at A, and then you have let's consider just assume like that. So bx by, right? So if you have this one, so if you draw the free body diagram of the other beam, so obviously bx and by have to be opposite, so like that. And then you have the 10 kilonewton going down here, and then at C you have, let's say, cx, cy, and moment, right? So let's say cx, cy, and mc, let's say like that. Okay, so what is not yet there, that is the distance, right? So you have 3 meter and 3 meter. Oops, so this is 3 meter, this is 3 meter, and then for this one 2 and 2. So this is 2 meter, this is 2 meter. Alright, so we have all the information, right? The width is not, ignore the width. Alright, okay, so to find this one, this should be sufficient. Alright, let's go. So for this one, if you want to find NA, summation of moment about point B equal to 0, let's consider clockwise as positive. So you have NA times the distance of 6 minus, because counterclockwise, minus 120 times the distance of 3 equal to 0. So NA should be 60, this is kilonewton, right? Okay, that's verify. Even though it's normally in the exam I try to verify anyway, right? Even though it's a simple calculation, just so if I make a mistake in my head. Okay, so 60. Alright, and then if you know that already, okay, summation of fx equal to 0 if you consider to the right. So there's no other force to the right, so bx is just 0. And then summation of fy equal to 0 if you take upwards as positive. So you have NA, which is 60, so 60 upwards, and then you have minus 120 going downward, and then you have plus by plus by equal to 0. So by will be 60 kilonewton, right? Now if you have this, if you go to the on this side, so we know already, what do we know? We know that bx is 0, by is 60. So this is equal to 0, this is equal to 60 kilonewton, right? Right. So based on this, if you do summation of, okay, what do we need here? Okay, if we do summation of a moment about point C equal to 0, if we take counterclockwise as positive, so you have MC counterclockwise, and then plus 10 times 2 from this 10 kilonewton, and then plus 60 times 4 equal to 0, right? So that means it'll be negative value, right? 10 times 2 plus 60 times 4, you get 260. Bring to the other side, so MC equal to negative 260 kilonewton meter, meaning that direction, right? And then for summation of fx equal to 0, taking to the right, so summation of fx, so we have bx is 0, cx will be 0 as well, right? Cx equal to 0. Then you have summation of fy equal to 0, taking upwards as positive. So you have minus 60 for by, so minus 60, and then minus 10, minus 10, minus c, minus cy, right? It's also downwards. equal to 0. So basically take to the other side, Cy equal to negative 70 kilonewton, meaning it should be upwards. Is it? Meaning it should be upwards. Okay, interesting. Is that correct? Yeah, because that's 60 and then that's 10, so it should counter, right? Alright, so those are the support reaction, and which one we will use in our calculation depends, because it depends which part do we want to use, right? So let's take, okay, I hope we can see the smaller side here, right? So let's take for this one, let's take this one, right? Let's take this part, right? If you take that part, okay, so we have to go here, right? Okay, if you take that part, free body diagram of AD basically, right? When you after you cut, so basically you have A to D, and here you will have this, right? Right. So this is VD and DMD. Okay, so from this operation, so we have this force here, but this is from this half part, right? Because when you divide, okay, so if you divide like this, okay, let's this one. After you divide, the distributed loading is not from the origin, it's from this part only, right? Because this only part that you know, applied here, right? You can do not consider this one. Do not straight away okay, so do not straight away use this one 120, because this 120 is the whole thing. You have to recalculate for that portion only, right? So basically you have 20 kilonewton per meter times the distance of 3 meter, so you'll get 60 kilonewton there. And then the normal A, we already have 60 kilonewton, right? 60 kilonewton. And then for the distance, it will be, because it is halfway, so this is 1.5, the whole thing is 3 meter. Right, so to calculate, if you take, let's start with the easy one. Summation of fx equal to 0, taken to the right as positive, so you have nd equal to 0, because there's no other force. Summation of fy equal to 0, taking upwards as positive, so you have 60 minus 60 minus vd equal to 0, so somehow vd equal to 0 as well. That's interesting. And let's go down a bit. Summation of moment about point D equal to 0 is about point D right here, and we took that direction to make it easier, so let's take counterclockwise as positive, so you have MD, and then you have 60 here going down, going counterclockwise as well, so plus 60 times the distance of okay, so what we need is this distance, which is 1.5, right? So this distance is what we use, 1.5. Alright, so times 1.5, and then 60 kilonewton clockwise, which is become negative, so minus 60 times the distance of 3 equal to 0. So if you calculate this, 60 times 1.5 minus 60 times 3 becomes 90. So become negative 90, but bring the other side become positive 90, right? So MD equal to 90 kilonewton meter with the direction, the conventional direction. So that is internal loading at D. What about this one, right? Of course, okay, if you try to use this, oops, sorry, if you try to use, what happened here, it should give you the same answer, right? You can try, but because I'm chasing time here, we have another 8 minutes to solve this for that 45 minutes, so let's straight away use, so I'll be using, which side is easier? So let's take a look this side, right? This side, I'll be using that side. All right, so for that one, I'll draw free body diagram of part EC. Now, so part EC, so meaning that NE is here, VE is here, and then ME is here, right? And then we have, okay, that's 10 kilonewton. Again, it says just to the right, meaning that when we take the portion on the right, it's within that, so it's here, right? Okay, alamak, tak muat pula. So let's where's the so let's write it here, right? So this is VE, and I have here just there at that point also 10 kilonewton. Right, and then all the support reaction is already found up here. So Cx is 0, Cy is 70 kilonewton, so it should be upwards, so 70 kilonewton upwards. So we have 70 kilonewton upwards, and moment is 260, should be clockwise, so we have 260 kilonewton meter clockwise, and then we don't have anything else there within this portion, right? The distance is 2, right? This is 2 meter, this whole thing. All right, so let's do one by one. So summation of, let's easy one first, summation of fx equal to 0, so you'll have, if you take that way, so minus ne equal to 0, and E equal to 0, so that one. So summation of Fy equal to 0, if you take positive upwards, so we have VE upwards and then plus 70 upwards equal to 0, so VE equal to minus 70 kilonewton, meaning in this case it's downwards, right? And then if you do take summation of moment about point E equal to 0, let's take clockwise as positive to be consistent with that one, so clockwise as positive, so you have ME for this one, and then 10 here, wait, is this 10? I forgot about this one, right? Because this 10 I didn't draw, so it should be 10 here, right? Okay, let me see. This one, is it correct? Okay, I'm running out of time. Okay, I'll do the moment first. So it's moment about point E. This is 10. Okay, ME. 10 is not having a distance, but then you have plus 260, and then minus 70 times 2. Minus 70 times 2 equal to 0. So you have 260 minus 70 times 2, you get 120, so ME equal to negative 120 kilonewton meter, meaning it's the opposite direction lah. Meaning it's counterclockwise, Now, this one, because we do not include this 10 kilonewton, right? So, Okay, so if that's the case, okay, we have 3 minutes left, so I think I have to extend this time, meaning taking the time from other question then. So okay, VE upwards, but then you have the 10, right? So you have should be minus 10 here, right? Okay, to 0. So in this case, this will become 60. So it's minus 60 kilonewton. Now, just to verify, we have another 3 minutes, so I definitely have to find to take the time from other question. But here, because we take on the right, if I take on the left, on this left here, right, because it should give the same answer. So if I take on the left here, so you'll have NE VE and ME. On the left side, that 10 kilonewton should not be there, right? Because this says point E. Oh, okay, I read it wrong. Okay, sorry. So this is why I get it wrong. 10. Okay. Point E is just to the right of 10 kilonewton. Okay, so if point E is to the right, meaning when you cut at point E, it does not include the 10 kilonewton. Okay, so let's verify this. Now this is good if you have mistake like this, and you are rectifying. If this happen when you are making an exercise or making a revision for the final, it is bad if it's actually happen in the final exam, right? So make sure you have practice so that you anticipate anything and check before you waste time like this. All right, so in this case, this will not be there, so this will actually be 70 kilonewton, right? Let's verify with this one. So if we take to the left side, this portion here, so meaning that 10 kilonewton should be there, right? 10 kilonewton, because the point E is just to the right, so meaning that if we draw the left side, so that 10 kilonewton should be there. And then at point B, we have this, right? So Bx is 0, By is 60 going down, so you have 60 kilonewton going down, and that's it, right? Okay, so we have that one, so it should give the same answer, but just to verify, we actually 420 already, but this is injury time, and we take from the other question anyway. Okay, given this one, so I'll use different colors so that it's not confusing on the other side here. Where's my mouse? Okay, so because if you do summation of fx equal to 0, that's straightforward. Then you get NE equal to 0, so it's the same. If you do summation of fy equal to 0, let's verify this one. So here you have minus 60, this 60, and then you have another 10 here, minus 10, and then minus VE equal to 0. So you have VE equal to minus 70 kilonewton, which is the same answer, right? Of course, on this free body diagram, negative means it goes up, and on the left side here, meaning it goes down. But we just follow the convention, meaning that when VE, the answer is just negative. So there you go. You can see that the answer is the same. And if you do moment about point E, summation of moment about point E equal to 0, if we take counterclockwise as positive, so we have in this case 60 times 2, that is positive, and then nothing else, 10 is on that dot, so plus ME equal to 0, so ME equal to negative 120 kilonewton meter. So it should be the same, right? So both sides, you can see that the answer will be the same, right? So just like this one is 0, this one is 0, this one minus 70, this one minus 70, this one is 120, this one is 120. Alright, so looking at the time, we actually exceed 2 minutes out of the 45 minutes. Right, of course, meaning that the next question will have to reduce by 2 minutes. Alright, so there you go. We have answered question 1A and question 1B. Including the panic that I have when I noticed I thought I made a mistake, and because I read the question wrong. I thought the force is on the right, but the point is on the right? So make sure, if you have done this, if you realize this kind of mistake, when in the exam you read 2-3 times at the beginning so that you do not repeat the same mistake. Alright, so let's go and move to question 2. Okay, this is question 2A. Question 2A. So again, we have 45 minutes, but we have already eat up that several minutes there. So it should be from 4:20 to 5:05. Now it's from, I will not change that time, so meaning that this is until 5:05. Alright, and we have two parts, part A and also part B. This is interesting, but we go for part A first. Maybe this one, let's have a look here. Okay, right. Hopefully you can see this. Figure 2A, this figure show a frame with external force as shown. So we have here 10 kilonewton there. Determine the force P, so here P, right? And the distance X. This is the distance X. For a structure to be in equilibrium. Note, any equation and subsequent calculation that is not clearly indicated to be corresponding to any specific free body diagram will be ignored and not considered. Right, because there will be several multiple free body diagram that you have to draw to solve this one. So this question specifically say, if you do not do free body diagram, we'll just ignore that calculation. So please draw. Now, what to do here? Of course, the main thing, the main thing is, as you can imagine, is about this one, this beam here, because there's force downwards and then there's the force upward from the cable. But if you can go here, because these forces are not known yet, right? This forces here, right? And this forces here not known yet, right? So we have to focus on the pulley. Okay, this pulley is just one cable, right? So we have to focus on this pulley first. Right. So let's do this. All right. So let's take a look at the important information first. This is question 2B. What is needed is P equal to what and X equal to what. That's in the end, right? Now, let's focusing on pulley C first, right? So, free body diagram of pulley C. So, if you draw the pulley, you have force here, P. And of course, from understanding, you know this should be P as well, because this is the same cable, right? And then let's name this T. Right, so that's the free body diagram basically, right? So what do we know here? If you do summation of Fy equal to 0, let's take positive upwards. So T minus P equal to 0. So T equal to 2P. Right, and because this T is, we know this is the same cable until point A, so now we can draw the free body diagram of the beam. Okay, so now free body diagram of beam AB, basically AB plus there, but let's name it there. So we have this beam. So we have this force here, and then we have the force here, somewhere there, and then we have the force down here. This one is already given as 10 kilonewton. Above here, this is P, right? And this is actually T, but it's equal to 2P from above here, right? And then to the distance, right? So one is this from A to this point is given as the distance x. Now here is quite interesting because the distance 0.9 is okay. Let's go there, right? The distance of this, let's use this color. The distance is from here to here, right? But the distance from, for example, A to B, this whole distance is not the same exact, right? Because in this case, this is the same, right? This is the same. I hope you can see that. But this one, so you have to add this to this 0.9, right? So 0.9 plus the radius. The radius is given there, basically 0.1. So basically the distance here is 1 meter, right? So that's the thing about the distance. Make sure you realize that the distance is not to this point but somewhere before, and there's a gap there which is the radius, right? Okay, now that is if that is okay. What is okay, sorry. Now with that is okay. Oh, I draw it with a different. Okay, so this is 1 meter, right? So if we want to compute, so summation of summation of Fy equal to 0, taking positive upwards, we have 2p plus p minus 10 equal to 0, meaning p or 3p equal to 10, p equal to 3.3. Is it 3.3? No. 10 divided by 3 is 3, 3.33, right? Kilonewton. So that's the answer for that one, for P. Right? Now, so let's use a moment about, okay, what is the point? This is point A, right? So this is point A. So summation of moment about point A equal to 0. Let's take, which one is this here? Let's take counterclockwise as positive. So P here we already know as 3.33. So 3.333, sorry, 3.33, we'll use that one. Okay. Times 1 counterclockwise, and then minus 10 times x equal to 0, right? So x equal to 3.33 divided by 10, is it? So 0.333 meter. Right? So that's the answer. Or 333 millimeter. Correct? So that's what the question 1, right? P and X. Alright, P and X is solved. This is for question 2B. Let's move on to question 2C. So we have for 45 minutes until 5:05. Alright. Now, let's go to this question. Figure 2B. Okay, so let's go to 2B, right? 2B. Figure 2B show a plier that is clamping a hexagon nut. So we have the plier here, the whole thing, clamping this hexagon nut. If the clamping force on the hexagon nut is 60 Newton, okay, so the force on the hexagon nut is already given. Draw the free body diagram for the 4 components of the plier as well as the free body diagram of the hexagon nut. Okay, so the question here actually explicitly mentioned that you have to draw the free body diagram. So you have to provide that free body diagram of the 4 component. What are the 4 component? So hopefully you can see what are the 4 component here, right? So one is this component until here, that's one. Another is this one component until here, right? Another one is this one, another one is this one, right? That's the 4, and of course the last one is the hexagon nut. So that's the 4 component. Determine the reaction forces at A, B, D, and E, and force P. So what we need to find is at A, B, D, E, and this force P, right? So that is what we need. Now, so okay, let's list down what we need. What is this? Question 4B, right? Question 2B, sorry. Question 2B. So what we need is free body diagram of 4 members that is specifically mentioned, and okay, let's make this smaller here to put it on the side. And what is it? So okay, this is quite interesting because we have to find support reaction at A, B, D, and E. But hopefully, okay, let's make it bigger first. Hopefully you can see what is the different type of support here. B and E and C as well are pin support. They are pin support, so you have X and Y. But if you see this, A and D, it's not pin support. It's not like one single hole and then there's pin exactly there where you cannot move anywhere. Because here, if you zoom in, is something like this, right? Something like that, right? Where this pin is free to move here and here, but is restricted from vertical movement. So the reaction is always the normal reaction in the vertical side, right? So hopefully that is clear from what we have covered in the semester. So with that, if we draw the free body diagram, okay, before that, because we are identifying what we need, right? Free body diagram as well as, so the support reaction, so at A we have NA, at B we have BX, BY, at D we have ND, at E we have EX, EY, and the last one that we need is P. So all of this, what is the answer? Alright, so that is that, and let's draw free body diagram of the 4 member. So so the first one is something like this. Okay, something like that, and then okay, let's make it bigger here. Oh, I cannot see then. So because the other one is just the mirror of that one, right? So it's something like that. And then we have the 2 that is something like this, and then oops, something like that, right? And then we have the hexagon, basically there, and there, and there, and there, and there, basically there. Right, so let's use read for the forces. Now, it is given that the clamping force on the plier is on the hexagon nut is 60 Newton, right? 60 Newton, right? So here, this is clamping 60 Newton, 60 Newton. That means the reaction here will be 60 Newton, right? This should be opposite there, 60 Newton. Okay, that's settled. Now, this portion here, what do we want to call this AB portion here, is having point A and point B, right? And point B is linked to this one, and point A is linked to this one, somewhere there, right? Similarly down here, so we have down here E and D, and point D is linked here, point E is linked here, basically, right? Now we do one by one. Okay, so let's consider point A. Okay, at point A there's only normal reaction, right? So we'll just consider normal reaction there. So N A. So the corresponding for NA is this one, right? So this one. So if this upwards, we will consider this downwards, and A. So similarly with down here, because point D we have only normal reaction, so we'll have here and D, the corresponding will be upwards here, and D. Oops. Right. Okay, for this one you have also point C, right? Because this point C and point C. Okay, so we'll do one by one. Let's consider point C, right? So if this point C is to the right and upwards, if that is the case, so this will be to the left and down, right? So if you have CX, CY, so this will be CX, CY. Now, for point B, we have BX and BY. So let's assume this direction, BX, BY. So that is corresponding to this point here. So the opposite will be that direction and that direction, right? So BX, BY. So here we have point E, right? So let's consider that one. So EX, EY, if you consider that direction, so the corresponding one over here is EX will be to the left, EY going downwards, right? Now, so this is okay. Another force is actually on the end here, so we have P and also P. As you can see, this is quite interesting because everything, the dimension is just the same, so it mirror, right? So as you can see, these two mirror each other basically, and this as well. Okay, the rest is dimension. So in this case, let us see. From hexagon to B is 10 millimeter, so this is 10 millimeter. And from B to C, okay, because C is not existing in this one, so from B to A is 30. So this is 30, right? So it's exactly the same down here, right? This is 10, this is 30. Now for this one, because so from E to C it's 15, so this is 15, this is another 15, right? From C to A another 15, and this is 95, and it goes both way. Down here is the same as well, 15, 15, 95. Alright, so all of those are the, now we have everything here. Next we need to calculate, right? So we have to label it somehow, right? So let's say, because otherwise it's confusing, so let's say I use this is 1, this is 2, this is 3, this is 4, and this is 5. Let's label it as such. So let's solve, because we need AD, AD, ED, B, D, E, right? Alright, so okay, I'm gonna copy this just to make it easy for this illustration, even though because in your paper it's easy to see this one, right? But for me it's going scrolling up and down, it's confusing, so I'll just copy it there so that the calculation is close to the free body diagram. Alright, so from based on free body diagram 2, if I take summation of moment about point B equal to 0, let's consider clockwise as positive. So we have NA times 30 and then minus 60 times 10 equal to 0. So NA equal to, where's my calculator? So 60 times 10 divided by 30, you get 20 Newton. That's one of the answer that we need, right? So that's one. And then do we need to solve for B? We need, right? Bx and by. Alright, so now, so straight away, summation of fx equal to 0 to the right, bx equal to 0. That's another answer. Summation of fy equal to 0 upwards. So you have NA, which is 20, minus by plus 60 equal to 0. So you have by equal to 80 Newton. Right? So that is complete. So we have NA, bx, by. Nice. Alright, so next NDEX EY. Okay, so I think we'll focus on this one, right? So this one here. So based on free body diagram 4, summation of moment about point E equal to 0. Let's take counterclockwise positive. So you have ND times 30 minus 60 times 10 equal to 0. So ND equal to 20 Newton, because this is exactly the same calculation as the one above, right? So it's repetitive basically. This is a bonus basically for you, because the exact solution is mirror the other one. So summation of fx equal to 0. So you'll get ex equal to 0. That's the answer. Summation of fy equal to 0 upwards. Then you have nd is 20, negative 20, negative 60 plus ey equal to 0. So ey equal to 80 Newton. Right, so you have also solved this one. Now what you need left is P. So for P, it's up to you whether you want to use 1 or 3. It will give you the same answer, right? So let's just take this one. Okay, so based on free body diagram 1. Now again, as the question actually highlighted that any calculation that is not clearly linked to any free body diagram, so of course you do not need to repeat this free body diagram. For me, it's just to see side by side, because the screen is limited. If you are on paper, it's easy to just see the whole thing. But you have to declare this is based on which free body diagram. Otherwise, if you straight away just calculate something and it's not clear which free body diagram are you referring to, then the question say it will be ignored. Make sure you take that note, right? Now, okay, for this one, because we have calculated already, right? So let's just take all the numbers that is relevant. NA 20, so NA here is 20 Newton. EX EY EX 0 EY 80, EX 0 EY 80. CXY we do not know, right? We haven't solved, but we do not need to, because we just want to have P. So we can take summation of moment about point C equal to 0, because we don't care about that value, and we do not have also, but we don't have the rest. So if you take counterclockwise positive, so we'll have about point C. So we have P times the distance would be 95 plus 15, right? So 95 plus 15 equal to 110. So that one, and then NA is also counterclockwise, so plus 20 times 15. EX is 0, so no need to calculate that one, and EY is 80, so it's clockwise, so minus 80 times 15 equal to 0. So based on this, you can calculate, so 20 times 15 minus 20 times 15 minus 80 times 15, 900, and then divide by 110, so you'll get P equal to 8.18 Newton. So verifying 20 times 15 minus 80 times 15, so minus 900, but bring the other side 900, and then divide by 110, you get 8.18 Newton. So that's the answer. What else? So we have solved it all, right? Meaning that, so this is for 8B, and that's the end of question B, right? Because next is question 3 and question 2, so next is question 3. So yeah, actually the time frame given, if we use all of the 45 minutes, it will be until 5:05. So actually we have 15 minutes more. And actually, yeah, if you notice, if you have covered many exam question, right? If you notice that for frames or machine like this, normally if you know how to answer it, it doesn't take too much time. Because normally the question that is given in the exam, at least in this university, if you are watching from other different university, I'm not sure what is the way the question are made over there. But in this university, if you are a student in here in this university, taking this subject, normally the diagram seems complicated, seems scary, but if you have attempted before, if you have solved it before, you know that it doesn't take too much steps compared to some other question. So if you know what to do, actually the time usage is actually quite minimal. Same with here, right? And in many exam question, that normally is the case, because normally the longer question is from a different chapter. Anyway, all right, so we'll go straight into how to do this, because in question 3, if I want to allocate 45 minutes as well, so I'll recalculate my time, because now if 5:41, let's consider that at 4:50. So 4:50, if we go 45, it until 5:35, right? Alright, so we'll do that. We'll straight away go to question number 3, and we'll just jump into the next 45 minutes, even though actually we have the buffer of 15 minutes, but we want to see actually the allocation of time. Right, okay, so going to question number 3. So this is question 3A. This is question 3A. We have A and B, right? Right. So question 3a. The beveled gear is subjected to the loads shown in figure 3a. This figure. Determine all reactions experienced by the shaft. Okay, this is quite interesting question, because another question that looks, it can look intimidating. Some student will be scared by looking at this, but it's actually not difficult once you know, once you go into it. Sorry. So for the understanding first, right? The question simply say, okay, you have this one, and here you know it should be, this is fixed support, right? And then the force is already only here, right? And determine all reactions experienced. So reactions is only here, right? So if you have fixed support, that's even easier, because you have Cx, Cy, Cz, and then moment x, moment y, moment z, right? So you have 6 unknown there, and you have to solve all of those, right? So that's basically it. So let's draw the free body diagram. Again, we have to draw free body diagram to get the marks. Okay, so maybe 65. All right, I still want to see the, all right. Okay, let's move it a bit there. Okay, so this is question 3a. So we need to find all the support action. So basically we have Cx, Cy, Cz, oops, Mcx, Mcy, Mcz. Those are all the unknowns. Not all that we need to solve. Okay, should I continue? The battery is dying. Okay, let's try if we can make it in time. Alright, so free body diagram. First, free body diagram. So basically we have the whole thing there, and then we have whatever there, right, with a certain radius. Let's just simplify drawing there, something like that. And then we have the force along x-axis. Okay, it's okay. If you look at this line, meaning that it's parallel to y, and then this line means it's parallel to x, so it's actually on the plane. So that's make it even easier, right? So it's somewhere there, where in this direction you have 550 Newton. In this direction you have 300 Newton, and going down you have 900 Newton. And basically you have, let's assume everything in x direction, not x, in positive direction, positive axis direction. So you have, this is Cx, Cy, Cz, Mcx, Mcx, oh, like that, Mcy, Mcz. Is there any dimension? 20 cm, so this distance is 20 cm and this distance is 8 cm. Of course, this distance will be used in the moment calculation, right? Okay, so there you go. Uh, okay, so let's start with the easiest one first. Summation of forces. So summation of Fx equal to 0. So the reason why in 3D I always assume everything in positive direction over here, so that it's we just use the convention, because to indicate which one is positive and negative in the forces, it will be not as easy or clear as 2D, right? So assume everything is positive, so it's easy. So then here you have Cx, and then you have only one force in x component, right? So minus 550 equal to 0, so Cx equal to 550 Newton, right? Then summation of Fy equal to 0. You have Cy, and then you have positive 300 equal to 0, so Cy equal to negative 300 Newton. Wait, the value, is it correct? I have to verify. Yeah, 550, 300, 900. All right. And then summation of Fz equal to 0, so you have Cz minus 900 equal to 0, so Cz equal to 900 Newton. Okay, so that's the very straightforward, because this is bonus, at least so far, because the force are already given in straightforward x, y, z direction. Now, what about the moment? So let's start with moment about x-axis, right? Summation of moment about x-axis equal to 0. So one we have about this axis, okay. Now, up to you whether you want to use scalar or vector. Generally speaking, if all the forces are straightforward like this, I like to use scalar. But if you want to use scalar, you have to understand the rotation, right? So about x-axis, because okay, I didn't put the axis, right? So this is basically the x-axis, this is the y-axis, and above here is z-axis, right? So anything that rotate about x-axis. So here we have mcx, mcx, because we assume it to be positive, so it's straightforward there. And then we have okay, this 500, where's my mouse? Okay, the 500 here, it doesn't produce any moment about x because it's a long x. This 300 Newton here, it actually on the same level and it goes through x-axis, right? So it doesn't produce anything. So the only thing that produces anything about x-axis is this 900, and it produces counterclockwise, so it becomes positive. So 900 plus 900, and then we have the distance of 20 cm. Are we using cm here? Normally we use either mm or m, right? So let's use it. Okay, what is the equivalent? If to convert to meter, it becomes 0.02 meter, right? And this one becomes 0.008 meter. Is it correct? Sorry, that would be if it's a millimeter, right? 1000 millimeter is 1 meter. 100 centimeter is okay. So divide by 100 is 0. Okay, so that's wrong. 0.2 meter, right? And 0.08 meter. Right? 20 cm, 100 cm is okay. Okay, this is normally how I am if I answer the question, right? Because I want to make sure, because it is not worth it if you just put some value and you don't double check, triple check, and then you make a mistake in the exam, right? So yeah, yeah, this should be correct, right? 100 centimeter, right? Okay, so becomes 0.2 equal to 0. So mcx equal to 90 times 2 is 180 Newton meter, because this is already in meter. So wait, this brings, so this negative, right? Meaning it's clockwise again. So MCX positive, oops, MCX here positive, and 90 this positive as well, so it'll be the other one. Alright, so it become negative 180 Newton meter. Next, summation of my equal to 0. So obviously we have MCY because it rotates about Y. What about something else? This 900 rotates about Y. 300 no, because it's parallel. 500 no, because it's on the same level, right? So only 900 Newton here, and it's also rotation counterclockwise, so becomes plus 900 times 0.08, plus 900 times 0.08 equal to 0. So MCY equal to negative 900 times 0.08, 72, negative 72 Newton meter. 900 times 0.08. Alright, so next, summation of moment about Z axis equal to 0. So MCZ rotate about Z axis. 900 is vertical, not rotate about Z. 300 it rotates counterclockwise, and 550 is rotate clockwise. So alright, so plus 300 counterclockwise with the distance of 0.08, and then minus 550 times 0.2 equal to 0. So 300 times 0.08 minus 550 times 0.2. So MCZ equal to, bring to the side, 86 Newton meter. Again, 300 times 0.08 minus 550 times 0.2 minus 86, bring to the other side, positive 86 Newton meter. So CX, CY, CZ, we solved. MCX, MCY, MCZ, we solved also as well. So that is question 3A solved. So we begin 5:50, right, just now. So we use 15 minutes, so we have another 30 minutes. Alright, so let's go to question 3B. Alright, this is question 3B. So we have the diagram here. Figure 3B shows a man walking up a ladder. If the 80 kilogram man stands in the position shown, so the distance is given, determine all loads acting on the ladder when it is on the verge of sliding. This is impending motion situation, where the friction equal to the static friction equal to the maximum friction, right? Take coefficient of static friction between the ladder and the wall at C to be 0.3. Okay, several things here. So let's just make sure we take everything. So 80 kilogram, so meaning that we have the weight here based on 80 kilogram, and then we have friction at ladder and wall C. So friction here, right? So because this is meaning because his weight is pushing it down, so we have a friction going up where mu s is this 0.3. Right. So what are the other forces? Obviously we have the normal reaction here, And here, because this is it's stuck in on that one, so it should be reaction here, and oops, reaction upwards as well. So all those are all the forces, and the question ask, what the question ask? Determine all loads acting on the ladder. So meaning all of this, right? All of these have to be solved. All right. So let's go. Question 3b. Okay, let's take a look at it. Okay, so in this kind of question, we have to have free body diagram, right? So we have the ladder. What's the angle? Oh, the angle is 30, right? So it's not that steep. Right, because the angle there is 30 degrees. Okay, let's use a different color. So we have a weight somewhere there of 80 kilogram. So 80 times 9.81 Newton, right? Okay, again, so we have normal reaction here, normal reaction C, and then we have friction here, because it says on the verge of sliding, so because it become mu n, mu s n, right? So 0.3 and C. Of course, this only becomes mu s n when it is impending motion, but the question actually say it is impending motion, right? And then we have both of these are actually normal, but because it's at the same point, so let's use bx and by. And we have the distance, right? So the angle is here. Okay, the distance, the perpendicular distance from there to there is 1.5, and the perpendicular distance here is combination of 0.65 and 0.35. That's 1, right? 1 meter. 1, right? It's 100. It's 100 millimeter. Sorry. Okay, there's a mistake here, right? I think I remember, because this is not the question that I made. So there's a mistake in the unit here. So it should be 0.65 meter and 0.35 meter. So it becomes 1.0 meter, because this is typo. So okay, so this is point B, this is point C. All right, so that's the all the information we needed, and we can calculate, right? Okay, so how many unknown do we have? We have 3. So easiest way is to take moment at point B, right? So summation of moment about point B equal to 0. Let's take counterclockwise as positive. So moment about point B, so this no moment, and then this one. Okay, in terms of the distance, okay, let's start with NC. So NC is counterclockwise, so NC, and the distance is, because the whole distance is what? The whole distance between this and this is 2.5 then, right? So and the angle is 30 degrees, so we want a vertical angle, so times 2.5 sine 30 degrees, so we get the vertical angle, right? And then this one is also counterclockwise, so it becomes plus 0.3 and C, and then the distance is the horizontal, which is 2.5 cos 30 degrees. That's this one. And then the weight, that's clockwise, so minus 80 times 9.81, so that's we haven't calculated yet. And then the distance will be 1, it should be horizontal, right? 1 cos 30 degrees equal to 0. So based on that, if you calculate okay, how to calculate this one? So we calculate the NC first. 2.5 times sine 30 and then plus 0.3 times 2.5 times cos 30. What is this? 1.8995 and C 8995. Okay, double checking. 2.5 times sine 30. Oh, sine 30. 5.4. And then you have 0.3 times 2.5 times cos 30. So you have 1.8995. Okay, so this value on the right here is 80 times 9.81 times cos 30, and bring to the other side, become positive, so equal 679.6567. 679.6567. Okay, so 679.6567 divided by 1.8995. So NC equal to 357.8. This is in, what is the value? Newton. Newton. Right? So 357.8. Is this one of the thing that we need to calculate? Yes, right? Okay. Of course, okay. Because we need to calculate the friction as well, right? So because the friction is this, actually, this is the friction, right? Friction. Because the question say find, what is it? Determine all loads. So friction is load as well. So let's calculate the friction. So friction force is 0.3 and C equal to, so we have 357.8 times 0.3, 107.34. 107.34. Alright. Now next is just summation of fx, summation of fy. Summation of fx equal to 0, taking to the right as positive, bx minus nc, minus 357.8 into 0, so bx equal to 357.8 Newton. So that's straightforward. Summation of fy equal to 0, upwards. So by minus 80.9.81, 9.81, plus the friction, right? So we'll just use the value of friction, plus 107, or if we are referring to Freiburg diagram, then 0.3 NC. So 0.3 NC is 357.8, right? 357.8 to 0. That's all. 1, 2, 3. Okay, so by equal to six 0.46 Newton. Double check. Six 7.46. Okay, so we have solved 1 2 3 4 unknown, right? 1 4 3 4 unknown. Yeah, is that all? Actually, that's all for question 3b. Right. So again, so we have finished question 3 A and B, and now it's for 520. So actually from 4:15 from 4:50 45 minutes means until 4:35. So actually solve this question with 15 minutes left within that 45 minutes, right? Meaning that we use 30 minutes basically. And the previous question as well, we have 15 minutes, right? So by now we actually have 30 minutes extra. Right, so we move to question number 4. I think we'll go straight into question number 4. It's 5:21, or if we consider start from 5:20, let me write it down. So if it's 5 now 20, 45 minutes becomes 6:05, right? So let's do that. Let's try. Can we solve the remaining question, which is question number 4, in 45 minutes? Yep. Moving question number 4. So this question number 4 have 3 parts, A, B, and C, and based on 2 diagram here. Question A and B is from based on figure 4.4a, and this is based on figure 4b. This one. Alright, so we go one by one. Let's take a look at this one first. Determine the centroid of the shaded region. So we are talking about this one. What is the centroid of the shaded region? State the final answer as a coordinate. Clearly indicate how the area is divided into segments. So this is actually instruction that you should actually divide and clearly indicate how you divide and which segment is which. But it's already a hint that, oh, I have to divide. But you should know that already, right? Okay, so this, what we need to find is centroid and final answer in coordinate, right? So let's go 4a. So question 4a. So centroid is what, right? And we want the answer in coordinate, right? So what that's the coordinate, right? So that's just to remind us that the final answer should be in coordinate. Alright, so this is okay. There's 2 ways of dividing this, right? There's actually 2 ways. One way is this, and then the triangle, and then the this one minus that one, right? Or some actually prefer this, taking the whole thing minus this triangle and minus this one, right? So either way the answer would be the same. Either way the answer would be the same. You can try, but of course in the final exam I have to choose one, and my preference is normally just to divide it as such, something like that, right? That's generally my preference because it's easier. Not easier, because either way it's actually the calculation step is the same, but the other one you have to minus. Normally I prefer what is visible, so add minus in the whole. Alright, but either way you can try, the answer will be the same anyway. Okay, so for this one, can I see the, because we have to refer to this one, right? Okay, so let's based on that, we have to see it. All right, so how do we divide? So what I would do is basically this is equal to this plus this minus this, right? So that's basically how I divide it. So basically that indicates it, or I can also say that this is how I divide, right? So basically this is 1, this is 2, and this is 3, right? Okay. So the thing here is, I think one important thing for you to do is, because normally we will solve this in terms of a table, and that is based on the equation, right? So we want to have a centroid, so meaning we want to find x and y as well. So x bar equal to summation of x with a divided by summation of a, while y bar equal to summation of y with a summation of a, right? So based on that, we make the table first. So we have the segment, and then we have the area, and then we have x with y with, this is the coordinate, and then we have this calculation, right? X with a, y with a, right? Now segment 1 is the rectangular, so segment 1. So let's take a look at that one, right? So segment 1, so if we, now the rectangular is, if you can see that bottom here is 8 and the rest is 9, right? So basically it is basically, let me use this, right? So this is 8, the height is 9, right? 8 and then 9. So the area will be 8 times 9, which is 72, right? Okay, what about the x wave? This is the x coordinate, right? So let me just have it something here, right? So for the rectangle like this, oops, okay, if I divide like this, you can see, right? This rectangle, the center is somewhere there, right, at the middle. So the coordinate should be from the origin, right? So meaning that the x coordinate, because the whole thing is 8, so it should be 4 and 4, right? If you divide this and this, it's 4 and 4. But the x coordinate should be here, right? So 4, this is 2, so actually it's minus 2. So in this case, oh, why is it blue? Anyway, it's minus 2, right? And the y coordinate is the height there, right? Is this distance here, right? So this is 9. So halfway is 4.5 minus this one, meaning that this is 0.5 positive. Alright, so that's it for this one, meaning the raw data, right? And the rest is calculation, so we calculate later. So next, segment 2. Segment 2 is actually the rectangle, and if you see the rectangle, the this one is 6, so this is 6, and the height is still 9, right? So based on that, the area is half times 8, not 8, 6, right? 6, 9, right? 6 and 9, right? So half times 6 times 9 equal to 27. Right? Now, based on the triangle, we know the ratio of 2/3, 1/3, 2/3, right? So it should be somewhere there, roughly somewhere there, the centroid. Now the x width is basically this distance, right? What is that distance? So the whole thing is 6, meaning that this is 2 and this is 4, right? In terms of the ratio, 1/3 and 2/3. But the coordinate should be from here. Sorry. So meaning that 2 plus 2 equal to 4. Right? So we have here 4. And the vertical distance is this one, right? So based on this, total height is 9. This is 3. This is 6, right? Meaning 1/3, 2/3. So this is 3. This is 6. But the coordinate is from here to here, meaning this 6 minus 4 becomes 2, meaning positive 2. So positive 2. Right. Next is segment 3, which is the hollow circle. So with that, okay, let me use this one because it's negative. So the area is negative area, then pi r square, right? Pi 1.5 square. So this is what? 9/4 pi. Okay, 9/4 pi. Okay, I'll leave it as such first, so that will not be decimal point, right? And then we will just calculate afterwards. Okay, for x, no, for because it's here, right? Oops, what am I doing? Okay, so it's there. So the x wave is simply -3. So -3. Y is +2. The rest is calculation, right? The rest is calculation. So let's calculate. So 72 times -2 becomes -144. 72 times 2 is 144. Alright, and then 72 times 0.5 is 36. So 36. 27 times 4 equal to 108. 27 times 2 is 54. Okay, 9 divided by 4 times pi times -3, so minus 27/4 pi 4 times pi times 2. So this one become 9/2 pi. Of course, if you want to use decimal point, no problem, but normally I prefer, generally speaking, to avoid error until the very end. Alright, so this is just the summation. So we have 72 plus 27. Oh, sorry. Okay, I just realized I make a mistake in terms of the negative. So I forgot the negative here. So this negative, meaning this is negative. So negative times negative, this become positive. Negative times positive becomes negative. This one negative there. Alright? Because this area is negative. So the multiplication should carry the negative, right? So this negative and negative become positive, then negative and positive become negative. Alright. So again, 72 plus 27 minus 9 divided by 4 times pi 91.93. 91.93. Alright. Next, minus 144 plus 108 plus 27 divided by 4 times pi minus 14. Where's my mouse? Minus 14.79. Again, minus 144 plus 108 plus 27 divided by 4 times pi 14.79 negative. Now 36 plus 54 minus 9 divided by 2 times pi 75.86. 36 plus 54 minus 9 divided by 2 times 36 plus 54 minus divided by 2 times pi 75.86. Alright, so the rest is just application of equation. So x bar equal to minus 14.79 divided by 91.93. 14.79 divided by 91.93. Oops. Negative 0.1609. This is meter or something. Okay, we'll check the unit, right? So again, minus 4.79 divided by 91.93. 0.1609 negative. Alright, y bar equal to 75.86 divided by 91.93. 75.86 divided by 91.93. 0.8252. Alright, so the coordinate, because the question asks for the coordinate, so negative 0.1609, 0.8252. Alright, that's the answer. Now, for just meaning this is double check in terms of whether it's logical or not, right? So negative 0.1 should be somewhere there, and then 0.8 is somewhere there, right? Almost 1. So is it logical? It's kind of logical, right there. Now this is just to check if somehow if you make a massive error and suddenly the answer is illogical. For example, if the answer is somewhere here, that's not logical. It's not the center, right? It should be somewhere there in that region in this case. Alright, so that's what is it? Question 4A. Let's move on to question 4B. It's the same diagram, but we want to determine the moment of inertia about y-axis. Okay, determine the moment of inertia about y-axis. Clearly specify all equations used in the calculation. Clearly indicate how the area is divided. Alright, so let's see, because in this case normally this kind of question normally the table is given because you are not expected. It depends. I think it depends on your institution whether you are expected to memorize all of this. Now, for some things, normally it is expected to memorize. For example, rectangular 1/12 BH cube, because you have done use that a lot, especially including in the parallel access theorem. So normally we expect you to memorize 1/12 BH cube. But for the rest, for example, 1/4 pi r cos 4, 1/36 BH cube. I don't know. In this institution, you are not expected to memorize. The table will be given. But if you happen to come from other university, I do not know. Make sure you know the policy of that university or the lecturer, whether you have to memorize that, all of this, or it will be given. Okay, so for this one, we will divide the area just like what we have done in part A. It's just that right now we are using parallel access theorem to solve the moment of inertia. And make sure you realize what moment of inertia that the question want. In this case, about y-axis. So about y-axis meaning, okay, this is question 4b. So the question asks for Iy, right? Moment of inertia but y-axis of the total here, right? So the equation is Iy equal to Iy plus a tx square. This is parallel access theorem, right? Iy is equal to Iy prime. This is about its on centroid plus a dx square. Alright, so we will divide the area again. Okay. Okay. Okay, somewhere there. Now, so based on this, we'll draw. So this, again, just like the previous question, the way you divide is up to you. Meaning what? Meaning whether you want to add or minus, etc. Right? So this is going to be divided as such. Alright. So equal to. Okay. Basically, I need all the spaces here. So equal to the rectangle. Okay. In this case, okay. Let me draw first. But I need to refer, right? Okay, and then that way, okay, plus the rectangle, the triangle, and then minus the circle. Now, if you learn with me, you know that there's a certain way that I like to draw it so that the information is there and I will not make a mistake from the very beginning, right? So because the equation is this, right? Okay, because we only need this part, right? Okay, the equation is where is it? Okay, the equation is this. Iy equal to Iy prime plus a dx square. So dx is the critical information as well as the information as well, right? So so for the axis, so there's two axes that is important. One is its own centroidal axis. So if this is its centroid, so this is its axis, right? This will be y prime. And the axis of the original question, right? So this one, the axis is 2 meter from the side, right? So because the whole thing is 8 meter, the whole thing is, this one is 8 meter, and the axis is 2 meter from the side, right? So it's there, this y, right? Because this is 2 and this is also 2, meaning that the distance between the two is 2 meter actually, right? Of course, if you take just the dimension, this is 8 and this is 9, right? Okay, next, for the triangle, the its own centroidal axis is there, roughly 1/3 there. So this is y prime, and the axis is actually outside of the triangle, right? It's there. This is y axis, where this is 2 meter, and based on the 6, this is another 2, right? So this is actually 4 meter, and the dimension is basically, the whole thing is 6 the height is 9, right? And for the circle, the centroidal axis is basically just there. Oops. Basically there, y prime, and the axis is outside there, so it's here, right? The axis. So this radius is 1.5, and this distance, okay, sorry, now for this one we do not need this one because it's the distance given straight away with this one, right? So it's 3. This is 3. Of course the radius is 1.5, right? So all okay, confirmation. So the distance between the axis is 3. Yeah, -3. So yeah, 3. This one is 4, right? 2 plus 2, and then this one is 2, right? It's here, so 2. All right. So those are the information that we need. So okay, another information that we need is the equation. So that is what we refer to in here. For rectangle, if we take Ix is 1/12 BH cube, right? Or if we take 1 over Iy is just flip it, 1/12 HB cube, right? So here I write the Ix1 and we'll just flip it, right? 1/36 BH cube, and for here Ix is 1/4 pi r to the power of 4, right? Normally my habit is that because for some type, for example triangle, it just give you Ix, so I'll write everything Ix and I just flip for Iy. So that's my habit. All right. Okay, so based on this, we have to just this plus this one minus that one, right? And we will use this parallelized access theorem up here, and using this for its Iy prime. Alright, so meaning that Iy equal to, for this one is 1/12. Okay, I have to see the diagram. Okay. 1/12 9 8 cube. That's from there. 1/12 9 8 cube, and then plus the area is 9 times 8, and then dx square, right? Dx is 2 here, so 2 square. Okay, here then plus 1/36, so 9 6 cube, right? From 1/36 BH cube there, then plus the area is half times 9 times 6, and then dx is 4, so we have 4 square, and then minus, so minus the whole thing, so minus 1/4 pi r is 1.5, so 1.5 to the power of 4, and then minus pi r square, so 1.5 square times dx square, so dx is 3, so 3 square. Okay, so calculating, let's calculate portion by portion. So 1/12 times 9 times 8 power of 3 plus 9 times 8 times 2 square. So this portion is 672. Double check. 1 divided by 12 times 9 times 8 cube plus 9 times 8 times 2 square. 672. 1 divided by 36 divided by times 9 times 6 cube plus 1 divided by 2 times 9 times 6 times 4 square, 486. Here's my mouse again. Plus 486. Again, 1 divided by 36 times 9 times 6 cube plus 1 divided by 2 times 9 times 6 times 4 square, 486. Alright. Minus 1 divided by 4 times pi times 1.5 power of 4, then minus pi times 1.5 square times 3 square. So this one is minus 67.59. Again, 1 divided by 4 times pi times 1.5 to the power 4, and then pi times 1.5 square times 3 square, 6759. So if you add, so 672 plus 486 minus 67.59, 1090.41. This is meter, right? Meter to the power of 4. Okay, so that's question 4B, right? So from parallel axis theorem, you divide the area. Of course, you can try with, if you divide it differently, meaning that the whole big rectangular minus that triangle, the answer would be the same. Alright, so we go to question 4C. Question 4C. Determine the moment of inertia about x-axis. So this is about x-axis using the horizontal element. Okay, so we have to integrate, of course, and the question already specify using horizontal element for the integration, right? And then this is the area. Okay, so that's okay. First, based on the question, question 4C. So we want to find Ix, and we need to use horizontal element for the integration. Alright, so Ix for this element is Ix equal to integration of y squared dA, right? That is for this element, correct? Hopefully you remember, right? Which equation for which element. That is important. Now, so this is the area. So if I am to redraw it like this, this is the region, and we need to use horizontal element, right? Check, is it horizontal? Horizontal, correct. Horizontal element, and the equation is already given: y equal to minus h over bx plus h. Okay, this is interesting because this will be in term of h and b. Now, in term of the limit, because it is divided by horizontal, so it begins with 0 until h, right? That's the limit. Alright, so we have what we need. So we have what we need. So yeah, in term of the element, right? In term of the element, so what we need? We need dA, right? So the length is x, and then this is dy. So dA is simply x dy. Of course, we want to plug in x here, so we have to, meaning that from y equal to negative h over bx plus h. If you bring it to the side, so y plus y minus h equal to minus h over bx. So if we bring to the other side, macam ni, okay, we bring to the other side, so meaning that b goes up, so by minus bh, h goes down over h equal to minus x, right? And then it should flip. So basically, first we do this one first. By over h minus b equal to minus x. So if you multiply by negative, so x equal to b minus by over h. Right, so that's the thing. So meaning b minus by over h. So maknanya dA is b minus by over h dy. Right, so that's the thing. So we have to integrate. Oops. So we have to integrate. So Ix, so if I continue here, Ix equal to integration of y squared dA. So integration of y squared dA is b minus b over h y dy, and the limit will be from 0 to h. From 0 to h. Okay, so expand this first, so you have 0h by square minus b over h y cube dy. So if you integrate, you get by cube over 3 minus b over h y power 4 over 4, right? And then from 0 to h. So if you plug in h into y, so you get bh cube over 3 minus b over h power 4 over 4. So if you simplify this, we get 1 over 3 bh cube minus 1 over 4 bh cube. So 1 over 3 minus 1 over 4. 1 over 3 minus 1 over 4. 1 over 12. 1 over 12 bh cube. Right, now if you get this and you realize that this is a triangle, right? Because the area given, mana mouse. Okay, the area given, if you go here, the area given is triangle, right? And we know actually Ix equal to, if you this one, Ix, if you go here for triangle is no, is it triangle? Okay, because this is over its own axis, right? It shouldn't be 1 over 36 here, because this is about its centroidal axis. But if you do use parallelisity theorem, okay, we actually finished before 6:05, right? We have another like 5 minutes, and mana pula mouse ni? Just as an illustration, right? If you want to double check, right? Because we know for any triangle, let's say for any triangle, Ix about its centroidal axis is 1 over 36 bh cube, and if we have that is 1 over 3h, right? So from Ix equal to Ix prime plus a dy square, we can have 1 over 36 bh cube plus the area is, because this is h, this is b, right? The area is half BH, and then dy is 1 over 3h, right? 1 over 3h square. So you get 1 over 36 BH cube plus 1 over 2 BH times 1 over 9h square. So it becomes 1 over 36 BH cube plus this time 1 over 18 BH cube, right? And 1 over 36 plus 1 over 18, it become 1 over 12 BH cube. So in 2 minutes you can actually verify it's the same, right? If you understand the concept. This is just using parallelization theorem, and because 1 over 36 BH cube is already given in your here, right? But anyway, you do not need to do this, but this is just because normally if I have the time, I like to verify, because in this exam what we have done from the beginning, we have that 15 minutes from question 2, 15 minutes question 3 buffer, and now we still have like 5 minutes buffer. So that's why you actually have time to check and double check and triple check in your final exam. Alright, so that's all. I think because we have covered all of this question from question 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B, 4C. In total time, because so meaning that originally we should have another 35 minutes in the 3 hours exam time. So we have another 3 to 5 minutes to double check, triple check what you have done. Or you want to exit the exam early, that's also fine. But normally I would suggest, especially in the final exam, if you have time, just double check, triple check, because sometimes we do make mistake, and if you can identify that, we can save a lot of marks. Alright, so that's it for this exam. Hopefully this helps for anyone who needs this. If you do not need this, you don't actually need to watch this. This is just to help those who actually find this method helpful. With that, actually this 6 and I have to pray solat asar belum lagi. Alright, so with that, inshallah we end the video here. Hope this help, and all the best for you for your exam. And maybe if I have enough time for tomorrow, I'll do another exam if it still will be helpful in any way. Thank you, all the best. Wallahu alam. Assalamualaikum warahmatullahi wabarakatuh. All the best.